Skylab, America's first space station. Launched in 1973, Skylab was a bold adventure, taking research to new heights, influencing how we live and work in space today, and paving the way for our future explorations into the solar system. 3 Skylab crews completed about 300 experiments to answer questions about our planet, our universe, and living in space. The variety of disciplines included human physiology, materials science, earth science, technology demonstration, and even student experiments. Skylab was America's first foray into microgravity-based scientific and technological research and was an important stepping stone for the design, construction, operation, and utilization of the International Space Station.
Good evening, welcome. It's great to see you all here this evening. Thank you for joining Space Center Houston's May Thought Leader Series, From Skylab to Gateway, the Legends and Leaders in Space Exploration. I'm Barrett Shaver, Chief Development Officer here at Space Center Houston, and we are the official visitor center of NASA's Johnson Space Center, and we share the story of human space exploration, past, present, and future. And we're space enthusiasts. At Space Center Houston, our purpose is to bring people in space closer together. And our Thought Leader series, presented by UTMB, is one way we showcase how science and humanity power space exploration. We have a very special opportunity for you to hear from 4 legends tonight, which I'll turn it over to the panel in just a second. But first, as a courtesy, I just want to remind everybody to please silence your phones, not just for your neighbors here in the room, but we are recording this evening's discussion, and it will be memorialized for all posterity. And before I turn it over to the panel, I'd like to introduce Space Center Houston Thought Leaders Series sponsor, Dr. Ronak Shah, who's the Director of Aerospace Medicine Division, School of Public and Population Health at UTMB. Dr. Shah joined the University of Texas Medical Branch in 2022, and he serves as the Director of the Aerospace Medicine Division. He provides oversight of the Residency in Aerospace Medicine, a training program for physicians seeking to become specialists in this field. He is also responsible for a team of over 30 physicians and scientists who provide medical and research support to NASA both here in the US and overseas in Russia. Dr. Shah joined UTMB from NASA, where he spent the last 5 years as medical director of the NASA Johnson Space Center Clinic. And for his service, he was awarded the very prestigious NASA Exceptional Achievement Medal. Please welcome Dr. Shah.
Well, thank you for that kind introduction, and thank you all for being here this evening to join us. Good evening. In 1973, America witnessed the launch of Skylab, our nation's very first space station. Today at Space Center Houston, we proudly commemorate the 50th anniversary of this marvelous achievement in spaceflight history. It has been an exciting day filled with events, and tonight I cannot think of a more befitting way to wrap up the celebration than with a Thought Leaders lecture as we look back at Skylab's successes and look forward to how lessons learned will influence space travel and research for decades to come. As mentioned, I am Dr. Ronak Shah, Director of Aerospace Medicine for UTMB Health, who is a sponsor of tonight's event. It is an honor and privilege for me to stand here amongst this panel of distinguished individuals, people who collectively reflect the spectrum of what spaceflight excellence is all about. For 30 years, the Aerospace Medicine program at UTMB has collaborated with NASA to safeguard the health of those who travel into space and to improve health here on Earth. Much of what we have learned can be credited to the incredible biomedical and life sciences research undertaken upon Skylab. Skylab taught us many important lessons on long-term travel in space and the effects of weightlessness upon the human body. We owe much to Skylab and to its dedicated pioneering crew members. Tonight, I look forward to hearing more about how those discoveries aided in the development of the International Space Station and how they are continuing to influence the progress of Gateway and our future exploration into deep space. Thank you very much for joining us tonight.
And now I'd like to introduce Director of NASA's Johnson Space Center, Vanessa Weish. Johnson Space Center is the home to America's Astronaut Corps, Mission Control Center, International Space Station, Orion, and Gateway programs, and it's more than 11,000 employees. As director, Vanessa Weish oversees a broad range of human spaceflight activities, including the development and operation of human spacecraft, commercialization of low Earth orbit, and Johnson's role in exploring the Moon and Mars. She's received numerous awards and honors, including the Presidential Rank Award and an honorary doctoral degree from Coastal Carolina University. Director Weish was recently elected to the National Academy of Engineering, one of the highest professional distinctions accorded to an engineer. Please welcome Director Weish.
Thank you, Barrett, and good evening to everyone. As we celebrate the 50th anniversary of Skylab, it is a true honor to be here tonight with you and moderating this discussion with this distinguished panel of Skylab legends alongside representatives of the International Space Station and Gateway as we move into the future of human space exploration. So allow me to introduce the panelists. These are very distinguished people, so their bios are a little bit long, but, but I thought it was important for us to acknowledge all of their contributions. So first, I'll start with Captain Joe Kerwin, former NASA astronaut. He served as NASA Johnson Space Center science pilot for Skylab. He was the first medical doctor to fly in space, and he completed 2 EVAs, extravehicular activities for spacewalks. He was subsequently in charge of the on-orbit branch of the astronaut office, where he coordinated astronaut activity involving rendezvous, satellite deployment and retrieval, and other shuttle payload operations. Dr. Kerwin continued his leadership efforts and served as Director of Space and Life Sciences at Johnson Space Center from 1984 to 1987. In addition, Dr. Kerwin served as president of the Life Sciences Special Business Unit of Wiley Laboratories in El Segundo, California. Please welcome Captain Joe Kerwin. Okay, next up, Colonel Jack Lausma, former NASA astronaut. He served as command module pilot for the second manned Skylab mission, Skylab 3. On the 10th day, Lausma and Garrett took a spacewalk to replace film in an external solar telescope and to erect a second sunshade over the area of the station where a protective heat shield had ripped away during launch. The first Skylab crew had raised one shade to cool down the lab, but it had begun to deteriorate. After traveling 24.4 million miles and a record 59 days in orbit, they flew their Apollo ferry back to Earth on September 25th. He returned to space on March 22nd, 1982, as commander of the third test flight of the Space Shuttle Columbia. Because of bad weather at the prime landing site at Edwards Air Force Base in California, he landed Columbia on the lake bed at White Sands, New Mexico on March 30th. He retired from NASA and the Marine Corps as a colonel and was inducted into the U.S. Astronaut Hall of Fame on October 4th, 1997. Please welcome Colonel Jack Lausma. Michael Barrett is a NASA astronaut and physician. After completing internal and aerospace medicine training, Mike came to NASA Johnson Space Center in 1991. He served as a project physician and flight surgeon supporting Space Shuttle and Shuttle Mir missions. Dr. Barrett was selected into the NASA astronaut class of 2000 and has continued to train, work medical and life sciences issues for the crew office. He served as an ISS flight engineer on expeditions 19 and 20 and performed 2 spacewalks. He also flew as a crew member on STS-133 in 2011. Except for pauses as Deputy Chief of the Astronaut Office and Program Manager of NASA's Human Research Program, Barrett continues to train as an active member of the Astronaut Corps and works heavily with the Commercial Crew and Artemis programs in applying medical standards to new vehicle designs and operations. Please welcome Mike Barrett. And rounding out this distinguished panel is Holly Rydens. Holly became Gateway Deputy Program Manager in 2022. Prior to this role, she served as Chief Flight Director, leading NASA human spaceflight operations through the first commercial crew missions to the International Space Station and the preparations for the upcoming Artemis I mission. She was lead flight director for Expedition 16, STS-127, and the first SpaceX Dragon mission to ISS. Expedition 16 conducted 5 EVAs, primarily for PMA-2 ISS construction and recovery from a solar array failure. Holly also served as the flight director assistant to the chief for ISS and visiting vehicles, deputy chief to the flight director office, and completed a detail in the commercial crew program before her selection as chief of the flight director office in 2018. Please welcome Holly Rydens. So, 50 years ago, Skylab, America's first space station, and the first crewed research laboratory in space, lifted off on May 14, 1973, on the last Saturn V rocket. Skylab was a complex and complete orbiting home and scientific laboratory, where 9 highly trained astronauts lived and worked in teams of 3. A comprehensive program of scientific experimentation, the Skylab missions revealed unknown information about our capability to withstand long periods of weightlessness, about the adaptability of living creatures to the space environment, and about life itself. Now, each panel member will give brief remarks to open our discussion. Brief 2-minute opening remarks.
There are a great many stories to be told about Skylab, and I don't think I can tell any of them in 2 minutes. But I can say that Skylab was my ride to space, the way I looked at it. I wasn't going to go to the moon. I was a doctor, and here was the mission coming along to answer the questions that doctors had been asking for the entire length of the program. And the program manager saying, we don't have time to experiment on that now. We don't have time to do in-flight work. Afterwards, we'll let you do your thing. And Skylab was that. P.J. Weitz and I got going early in 1966, traveling to Huntsville to do EVA training in the big water facility to help lay the thing out, to plead for a window, and to work with that team. And on the day of launch, when the catastrophe happened and Skylab lost its heat shield, pinned down one of the solar panels and lost the other one, it was that engineering team in Huntsville and Houston and everywhere that really made this program work and saved it. It was terrific. I hope we get to talk about it more. Okay.
This one working? Hear me all right? I'm Jack. I flew on the second Skylab mission with Alan Bean, who was on the second flight to the moon, so he was our commander. And our science pilot was Owen Garriott, an electronics professor from the University of Stanford. And together we spent 2 months on the Skylab. We tried to stay longer, as a matter of fact, because the missions at that time were going to be 28 days, 56, and 56. So we performed very well. We got along real well. We did all the work. We got more done than anybody expected. And we thought, well, maybe we deserve to stay a little longer, at least longer than the next crew. And so about day 45, we said, we'd like to stay longer. We're having a good time up here. We're getting a lot of work done. We got more we can do. And so I think this is a good time to ask for about 3 more weeks. And they said, well, let me ponder that for a while. And a couple days later, they came back and said, you'll be able to stay 3 extra days in order to meet your ship on the water, but that's it. Because the last crew is probably going to stay longer than you would anyway. And so that we had to give up on that idea, but we tried to beat the record and didn't. But nevertheless, we were very successful in our spacewalking. We had 3 spacewalks, and the maximum length was 6.5 hours. And Owen, Gary, and I put a shade out over the umbrella that the first crew put up because it wasn't planned to last. And we had a very successful spacewalk in that occasion. And we did a lot of other things too. There were other things that were broken and needed to be fixed, and we carried along extra equipment and so forth to do that. So it wasn't just a matter of going out and changing the film and the filters and the Apollo telescope mount, but it turned out to be a lot of repair work. We tried to stay longer, as a matter of fact, and I told you that. But we decided that since we couldn't stay longer, we'd leave something for the next crew to see. And so we had a few extra days there. We did push-ups, with 3 guys on each other's back, and no arms, and just floating off. A few stunts like that. And one of the things, though, that I thought that the next crew was going to like is have to have some company when they came up there. Didn't want them to feel that they were all alone when they got there. So I found their clothes, and we had a outer jacket and a T-shirt and trousers all made of this ugly brown material. And we were changing those clothes every 2 days, or every 2 weeks, I should say, because we didn't have a washing machine up there. We just put on new clothes. So I found theirs, and I stuffed them with bags that would hold trash bags that would fill them out, and I made them all look alike, and they looked pretty good. And I put the first one on a bicycle. I thought it'd be a good place. And that was the bicycle that somebody said, if you just rode it for 90 minutes, you could ride a bicycle around the world. Not bad, huh? I put the other guy on the lower body negative pressure device, and that's the thing that held your lower body. And of course, what happens up there is your blood tends to settle in your abdominal area instead of your legs. And so if you want to make a comparison to being on Earth, you have to draw some of that blood down. So we had a can that we put our legs in and sealed around the waist and took the pressure out, and that drew some of the blood down in there to make it look as if we were on the ground. But the third guy, I put him in a place that NASA will not allow me to tell you where I put it. But I don't mind. I think this is an important piece of information. We had a waste management department up there, much different than anything we'd ever had before. And so we had a commode that was on the wall. We had a one-holer. If you're on a farm, you know what a one-holer is. And we would back up this one-holer and put a strap across our waist and do our thing. And so I thought that was a good place to put this third person. So despite the fact that I'm not supposed to say that, they found that person right there. One other thing I should say more technically, though, is what the Skylab contributed to the International Space Station. Because up until this time, our longest flight had been a Gemini flight, 2-man flight, for 15 days only. And so you got these 2 guys, they're in this Gemini capsule, they have all the room that you have in the front seat of a Volkswagen Beetle. to eat, sleep, waste, and sleep, and everything else. And so that was our longest mission in zero gravity, and we're going to go into an International Space Station and stay for months and years. But the Skylab took care of that. We learned how to build the International Space Station, how to orient it, how to outfit it, and how to do spacewalks, how to do all the kinds of things that you would like to do at home in a comfortable way. And that was all done in the Skylab and built into the International Space Station. So that was, I think, its prime objective.
Thank you.
Well, I was a teenager when they were doing all this stuff. But I will tell you that I was watching with incredible interest, and I always considered that something out of reach, but just something that was very magnetic and drawing. And I think a lot of us, when we saw the Skylab program pop onto the news, realized that there was something really big besides the moon race. We had just run the moon race. What else was there? All of a sudden, there's this big outpost. Instead of the cramped capsule we would see people in, you see what happens when people are free to be in space. You can do things like that. And it was really amazing. And I will tell you that I started getting interested in space medicine of all things. Believe it or not, at least half of you may have trouble with this. There was no internet. And I was trying to figure out, how do I find out more about this? So I went muddling about my medical education, kind of looking for signs and wonders. And my wife and I went to medical school together. She's in the audience. At Northwestern University Medical School, this portrait of Dr. Joseph Kerwin is outside the main lecture hall where we did all of our basic science lectures for the first 2 years. His legacy there was just legendary. And I realized there really was a way to meld these two amazing interests. I was lucky enough to come to the NASA Johnson Space Center in 1991, being trained in internal and aerospace medicine. And medicine was really the big draw. It's the human in space. It's how we're going to get somewhere. It's how we're going to explore. It is really where the rubber meets the road for the human race expanding. And here you can see the lens that I look at things through. It's very much that human outlook, that medical lens. How does the person behave in these extreme environments? And that book down there to the right, the Biomedical Results of Skylab, I teach in a lot of venues. That is required reading. It has incredibly relevant information still. A lot of times I see people reinventing the wheel. They did so much groundbreaking work back then that as a flight surgeon assigned to the Shuttle Mir program, we were flying people long duration for the first time since Skylab. I went and talked to all these guys in the early 90s and asked them if our science program was adequate. And I was telling Dr. Kerwin before, we got everything from this is about right to no, it's too much to you need to double it. So there was some diversity of thought among these guys. But we patterned everything we did in Shuttle Mir after the Skylab program. And after the first Shuttle Mir mission, which was Norm Thagard on Mir 18, I became the Med Ops lead for the station program. And we took the medical program, the daily work regime, the crew limits, everything like that baked immediately into the ISS documents. And so a lot of people kind of look at Skylab as a one-off program or a stepping stone in a way, but there was direct, continual infusion of what we did from Skylab into the ISS program. Believe me, the MedOps requirements documents, the international documents that we made are really fed directly from Skylab. So it's not like there was legacy there, it was infused. It is baked into the DNA of the ISS program and how we explore right now. So it's an amazing honor. Hopefully you can see that, to be next to these guys here because of what they contributed. I also hope you get the idea between Dr. Shah and Dr. Kerwin and myself, and there are other flight surgeons in the audience, that there is an international space medical mafia. We're organized. You'll never know we're here. But what we get to do is just really amazing. Let's go to the next slide real quick. And I don't want you to read this, but just understand that I teach in many venues. This is one of my 700-slide teaching deck. And I just pulled this out to say that I teach what we learned in Skylab still. It's contemporary, it's relevant, and so much of what we did that has never still been done again. And let me just end with the last slide, which is just one of my favorite juxtapositions. I don't know what it is about doctors playing with water in space. but there's a certain fascination with fluids, so I'll just leave it at that for now. It is a big honor for me to be here with these guys.
All right, well, it is certainly an honor to sit on the stage with this group of people, right? So flight directors, by the way, are also a mafia, and it is not very often that we are outnumbered. So I'm really, really confused about this. So, with 2 minutes, what do you talk about, right? So a little bit about, this group, this crowd, right? So one of the things that is amazing is that this is the history of space stations, but also the future, right? So I get to be the bridge. That's my job today because I represent our Gateway space station. We're working on the first 2 elements right now, building hardware, cutting metal. All of the hardware exists in places all over the world. And so it is extremely exciting to think that, there'll be another chair and another chair and another chair, right? So often when we have these discussions, we get to hear all of the lessons learned. And there have been different times before we did Artemis where you kind of wondered, where is it all going, right? And then we flew Artemis 1 just about 6 months ago, and now it's real, right? You get to see the rocket go up, and you get to see the capsule. We have our Artemis 2 crew. Artemis 3 land on the moon, right? And landing on the moon, super exciting. I know people will ask about being there before, but certainly for my generation, this will be the first time that we've been, and for many of you as well, right? And so we're gonna do it in a way that represents the world we live in today. We work with commercial partners, we work with international partners, different than when we started Skylab, and that's great, that's okay, that's representative of the world today. So our Gateway space station, right, platform for science, it'll live out in a near rectilinear halo orbit around the moon, an outpost. It won't be manned all the time, crewed, right, crewed. Like the International Space Station is, it'll be an outpost, roughly 30-day missions to start with. We could extend that over time. I was fascinated by the numbers you used, 28 and 56, and I'm like, we're using 30 and 60. Maybe we need to go work on our numbers a little bit, because it's very specific, right? But, so we'll be out around the moon, right, giving us the ability to land different places, giving us really the opportunity to do what I think of as the other half of the landing, right? So landing is amazing, but if we're gonna get to Mars, we have to continue to learn how to live and work in space. That was started by these gentlemen here in an amazing way, continued through the space station where I actually started, first element launch of the space station. So my background is all ISS up until when we flew, when I moved over to Gateway. And so then we will head and take all of that knowledge, into the future with the Gateway space station. So, think about that as you listen to them, that what's really important to us is that it is a continuation of the knowledge and the striving for getting out into low Earth orbit and into deep space that, doesn't happen necessarily in one generation, right? This is a difficult thing to do. And it's going to take all of us to continue. And so, for me, I started out in mission control, as Vanessa talked about, 20 years in operations. About a year ago, decided after the coaching of a couple of really good mentors, maybe I could learn more and do more. So I sort of stepped backwards in the life cycle. So, now I'm out here building, and then we'll be flying here in a couple of years, the first pieces of the space station, the Gateway space station. If you think about that, it should overlap ISS, right? So there should be no drop of knowledge and momentum between NASA's space station that we're flying today. There was a little bit of a gap, right, between Skylab and ISS, and that fortunately, there were people around like these gentlemen who could help us remember what to do. Unfortunately, it took us a little while to sort of learn how to continue to fly, in low Earth orbit for many, many years. And so hopefully we'll be able to continue that seamlessly with the Gateway space station. I think my 2 minutes are up.
Those were all excellent opening remarks. So we're going to start first with you, Joe, because I think maybe if you could talk about your memorable moments and also like challenges, things that occurred during your mission.
Excuse me. I was so excited I forgot the microphone. Of course, we launched 10 days after the catastrophe that occurred when Skylab went into space, tearing off the heat shield, losing one of the two big solar panels, riveting the other solar panel down so that it was useless. It was getting hot. It didn't have enough power. In 10 days, and I tried to say a word about this before, that engineering team thought of, designed, built, found, launched underneath our couches all the equipment that we were going to need to fix the two big problems, the temperature problem and the power problem. We got there about 8 hours after launch. Pete, I have to remind you all that Pete Conrad was our commander. He was the second man to land on the moon, the commander of the Apollo 12 flight. And his personality can be expressed by what he said when he stood on the moon. He said, "That may have been a small step for Neil, but it was a giant leap for me." He wasn't as tall as Neil. So he was a great guy, and as we waited for the booster to ignite, he said, "Guys, we got to think of something positive to tell Houston. They're a little bit worried." So as we lifted off, we talked about it, and as we lifted off, he said, "This is Skylab. We fix anything, clear the tower." And we thought so too. We got up to the Skylab, and he did a fly around. PJ took videos, transmitted to the ground so everybody would know what was wrong and how to get started. There was an aluminum strap holding down the solar panel. It looked like the only thing holding it down. We went over and soft docked to our docking system just to capture latches, talked to the ground, decided to go back and try a little spacewalk right there and then, see if we could pry that thing up. So we helmets and gloves on, depressurized the spacecraft, opened the hatch, and Paul Weitz goes out as far as he can. We're on fairly short umbilicals, and I'm holding him by the feet. And he's got a shepherd's crook on a 5-foot pole that he put under the strap and pulled as hard as he could. And the strap didn't go anywhere, but the two spacecraft started to close with each other. Conrad, got us back out. We said, "This isn't going to work, Houston." So we got back in the cabin and repressurized and went around the dock, go inside and get ready for a full day's work. And the docking system failed. The capture latches would not capture. Pete did it slower. He did it faster. He used a backup method. We were suddenly in a heap of trouble. And I have to go back to a day in training about 3 months before. We were looking at command module things, and Jake Smith was his name. Our trainer said, "Don't go home yet. I want to show you the second backup method for docking. You'll never use it, but these are the wires you cut." So there was the second spacewalk of day one. You're not supposed to spacewalk on day one, because if you get motion sick, you might throw up in the helmet, and that was frowned on so by us. But away we went. We depressurized again. We didn't have to open the side hatch. We opened the tunnel hatch to get at the docking probe, and I went up and cut I hope to God these are the right wires, I was saying. But they were, and the hard dock worked, and we went to work the second day, got the parasol out, and waited then for 2 weeks doing medical experiments, drinking cold coffee, turning out the lights, and waiting for the backup crew to get an EVA plan for us. Those were some highlights.
Wow. I can only say those were some highlights. Wow. So Colonel Lausma, could you maybe tell us some highlights and maybe challenges that you experienced as well.
Sure. I think that the Skylab was a really a challenge for all of us because nobody had stayed in space that long before. And so there were all the medical aspects that we had to learn about and so forth. And I recall getting ready to fly in the Skylab, and I wasn't sure I was going to be assigned. There was a time when, although the Skylab looked like it was going to fly, it wasn't totally sure. And so that worried me a little bit because I'd be run out of things to do. And but I had heard that there was going to be a flight with the Russians in 1975, and I thought, well, maybe that's my last chance to get on a Saturn kind of a rocket and fly out into space. So I better do something about this. So since the Skylab was so iffy, I took a course in Russian from the University of in Maryland, who they service military people off base with all kinds of different classroom types of training, so they can get their degree. So I took a course in Russian from them. Took about half a year, and I passed the final. And by this time, the Skylab was a little more certain. But I did, however, take my diploma up to the Deke Slate and said, if you have a flight with the Russians, I'm ready to go. And fortunately, however, the Skylab then came through. And we had this 2-month mission. And you think of the pictures you've seen of space and the pictures of the ground and so forth. We had an opportunity with the Skylab to see a whole lot more of the world than a lot of the Apollo missions did. Because every time we went around the world, every hour and a half, we'd spend 60 minutes in the daylight or sunlight and 30 minutes in the darkness. And our orbit was inclined to the equator at 50 degrees. That meant that we went to the 50 degrees north latitude, and that's the northern latitude of the United States. And then have a revolution later, 45 minutes, we at 50 degrees south, going under Australia. And besides that, during that hour and a half that it took to go around, the world had spun a certain number of degrees, and so our track over the ground was different every time. So plus 50, minus 50, plus 50, minus 50. And we didn't have constant communications like we have now. We could only talk when we were over the ground station. We didn't have any satellite communications whatsoever. And so we had different communication stations like in Spain, Bermuda, Australia, and different places around. We had 3 of them next to each other across the United States. So if your orbit took you across that, those 3 you could talk for quite a long time, maybe 12 minutes or so. So communications is a whole lot different. Sometimes you go around the whole world and never pass over one of those stations, and so you're up there all by yourself. And if the ground's got something to say to you, they usually monopolize that 6 minutes. If you went through the center of the cone, it was 6 minutes. If you went through the edge of it, it might be 30 seconds. So it varied, and we didn't have the same kind of connections that we have right now in those terms. But we were a little more independent on our own. And one of the things we enjoyed the most was to look out the window. You know, the Apollo guys didn't get much time to look at the Earth out the window, but we could look out the window anytime we wanted to. We had a big window in the wardroom. It was about so big. And if you were thinking ahead, you could take your freeze-dried strawberries in the morning and maybe mention this and put them on some ice cream and have an ice cream sundae while you're looking out the window. And when you're looking out the window at the Earth, you just see a part of it. You might see 500 miles or more, but you only see a part of it. But when you go outside, it's like being on the front end of a locomotive steaming down the track, because you can just see everywhere, and you're a part of this thing, and you're gliding right along with it, and you let go, and you're still gliding along with it. And if you get out a little too far, you have everybody come over and give you a boost and put you back in track. But I think the spacewalks were one of those things that we enjoyed the most. With the naked eye up there at 275 miles, you could see all the the blues of the ocean and the white of the clouds and the snow on the mountains, the green and brown patchwork of the farmers' fields, and the dense forests and deserts. And it was just like a brand new set of views every time you looked out the window. You could see with the naked eye a blacktop road over a desert, but you probably wouldn't see that blacktop road in a green area. You could see the wake of a large ship if you had the sun glinting where the wake was, but you could not see the ship. You're so far away you could not see the ship. So those are the kinds of views that we had. And we got pretty good at looking out the window. In fact, we got pretty good at getting our work done before it was time, and we had extra time, and so we asked for more work. And one of the programs they gave us to look was to look for certain sites on the ground, certain places, the plains of Nazca, the plains in South America, and other places around the world, and look to see if we could see them and make them out. And so that started a whole brand new program for all the flights that followed. They're called the Earth Observations Program, to see what you could see with the naked eye from the spacecraft and report on it, and became a plan that all the other flights that would be after us carried out. So there are a lot of things that we could see from there that we really enjoyed. At night, of course, you could see the northern and southern lights, and they're just beautifully, and they're whites and greens and glowing. And on both sides of the equator, when we were at plus or minus 50, we had very good views of those kinds of things. So we saw things up there that were not expected because they weren't seen in earlier flights because they're so short. So we passed those things along. I guess there are other things we could talk about. I haven't had a thing running. Oh yeah, let me talk about something before we left. We did a lot of training underwater in nutribuoyancy tanks in order to simulate our spacewalks. And of course, when you go underwater, well, you are going to float to the top, so you get weighted down. And especially if you're wearing a spacesuit, you fill it with air and you're going to float to the top, and so you get weighted down very heavily. But at some point between the bottom and the surface, you can float naturally, although it looks like you're floating, but inside of your suit, if you're upside down, you're standing on your head, you can feel that, but your suit's not moving. And so we had a very small water tank here in Houston. It was only big enough to put a command module in, so we could practice our upside-down escapes from the command module in there. But we didn't have a larger tank, but we needed something bigger for Skylab. And Werner von Braun, was the director of the Marshall Space Flight Center. He was, of course, the head rocketeer in Germany at the age of 28. He was making rockets to go to the moon, and he became Hitler's chief rocketeer on V-2 rockets and so forth, but escaped to the United States, and he and the Germans ended up at White Sands Missile Range and taught us how to make some rockets. And then they sent him over to Huntsville, Alabama, where the Redstone Arsenal was, and they worked there for a while, and out of that came the NASA Marshall Space Flight Center, and then Werner von Braun was the head of it. And he was the head of it when we first were assigned in 1966. We made trips over there to meet everybody, and we met with him and his engineers. And later on, he was wanting astronauts to come and live in Huntsville. So he made a huge nutribuoyancy tank, one big enough to put the Skylab in. He figured if he did that, he'd have astronauts move there and live there. But we just fly our airplanes, work for a day and 2 or 3, and come back home. And often when we were working on the Skylab mission, Owen Garrett and I were working to put the solar shade on over the parasol, and that was all developed at, that shade was developed at Marshall. And so we trained on it there, and often at noon, Werner von Braun would invite us up to his office for lunch, just the 2 or 3 of us, and he would also invite a couple of his buddies from Peenemünde. Now, Peenemünde was the name of the rocket company who made the V-2 rockets and the buzz bomb rockets that destroyed England. But nevertheless, he would invite us up, and he wanted to talk about the Skylab, but we wanted to talk about Peenemünde. And we all found it very interesting. So we had a lot of interesting things, not only in space with the Skylab, but also on the ground. I better shut up now, I'll probably put you to sleep. Okay.
So for the both of you, tell us about the exercising and eating on Skylab. There were reports, we want to know if this is true or not. Is it true that the doctors told you could only exercise when passing over the United States?
We had difficulty in the first week of the flight riding the exercise ergometer, the bike that we had up there, because we had designed a harness that pulled us too tightly against the seat, and it was cutting off circulation to our legs. And Pete, who was working harder on it than anybody else, was throwing a few extra heartbeats at his peak exercise. The doctors on the ground were worried, and they said, no more exercise on that thing unless you're over the stateside where we can watch every heartbeat, and Pete can't go on the spacewalk to pry up the solar panel. Well, Pete was a shy, retiring type of guy, so he said, Get me the administrator. And the administrator came up on the line, and they talked it over. I assured him that Pete was extremely healthy. He told us Pete told him that we were fixing the problem with the bike by taking the harness and putting it back in the locker and just riding it with our hands. And would you please tell the doctors to let us go? And the director said, okay, and he did, and we went out on the spacewalk and had a good time.
Awesome. So Mike, we recently memorialized Skylab legend Dr. Bill Thornton with a tree dedication ceremony at the Space Center. Bill was a member of the astronaut support crew for Skylab 2 and 3 and the fourth mission, and principal investigator for Skylab experiments. Can you share with us the importance of Bill Thornton's work during Skylab missions and his impact on human space exploration?
Well, sure, I'd actually be very happy to, although Dr. Kerwin, I think, knew Dr. Thornton much longer than I did. Dr. Thornton passed away, I think, at the age of 91-ish. I was still very busy academically in my role as associate editor for space medicine for our mainstream journal. I actually worked with him over the last 20 years or so. He never quit. But as he started, you can't emphasize how complex the Skylab was as a laboratory. It had lower body negative pressure, rotating chair, a body mass measurement device, which Dr. Thornton invented, EKG, blood, urine, poop, whatever. We could bank those samples and analyze them. Dr. Thornton was behind the development of a lot of the science on board and invented a lot of the hardware that we use. He had over 60 patents, actually. And what a lot of people don't know is that Skylab was preceded by an amazing project called the SMEAT project, the Skylab Medical Experiment Altitude Test, where we literally locked 3 people, including Dr. Thornton, in a chamber for 56 days, similar to your mission length. And we shook out I say we, again, I was a teenager, but it shook out all of the hardware and the experiments, and I have heard these stories directly from Dr. Thornton. I've read every account. Guess what? A lot of things broke. A lot of experiments failed and just could not have been done until they fixed things real time. And I think it was a truism, and it was certainly put on record that Skylab would not have succeeded without that SMEAT test, which Dr. Thornton had a huge role in making successful. So it's really no understatement to say that Skylab was successful because of Dr. Bill Thornton. He went on to become the second American physician in space. He flew on STS-8 and one other mission, and was also a bit of an inspiration to me, actually, because I got to watch this guy on TV and realized that Dr. Curran wasn't the only one. There was a kind of a lineage here. And I actually helped Dr. Thornton publish a paper about 3 years ago on space motion sickness. So again, he was active all through this time, but an amazing man.
Awesome. Thank you. So Joe and Jack, both of you perform spacewalks during your missions. How much contact did you have with mission control during your actual spacewalks? For both of you, yes.
With the microphone. Some, but not too much. We didn't have around the orbit communication, just over the tracking stations. So we would tell them what we were doing. They knew what we were doing at the start of the EVA to pry up the solar panel, which, by the way, I will briefly describe, if that's okay. We had a 25-foot-long aluminum pole, 5 sections, which Pete put together as we came out the hatch and handed to me, and I brought it down. The nearest place that we could position ourselves at all was about 20 feet away from the base of the solar panel. And we had to get past that base far enough to connect something to it to pry it up. So we used the pole to connect a telephone company limb lopper to the piece of aluminum strap. That was difficult to do. It took us an orbit to figure out how to stabilize me to do it, but we got it halfway down. We didn't want to cut it yet because Pete then used that pole as a handrail, and he went down to the base of the solar panel with another rope with a connector on the end of it, got out as far as he could, and connected that rope to the solar panel about 5 feet from the hinge. At the other end, I tied it around a handy stanchion. I didn't know how to do a half hitch, so I did a surgeon's knot, and to keep it tight. And then Pete and I both crawled under that rope and stood up, putting tension on the hinge. Well, they said it would take about 100 pounds, and I guess they were right, because just as we were straightening ourselves up, there was a snap, and we went off head over heels into outer space, connected by our stout umbilicals, of course. Pulled it back, turned around, and that thing was all the way up, and the little panels were starting to come out. That was definitely the high point of the day. But you know, to answer this specific question, all this happened out of range, and it was about 5 minutes after that when we went in range and heard the words, "Flight, we've got amps." And we knew that we had our power back and that Skylab was going to be fine.
Awesome. So for Mike and Holly, how did Mission Control adapt to more extended space missions, and how has it evolved over the years?
Yeah, it's actually really interesting to think about, right? So we fly the International Space Station continuously and have been for 20 years. So mission control, flight directors, flight controllers, and then our partners around the world, and sometimes our commercial partners, 24 hours a day, 365 days a year. When we go actually out and do Artemis, establish our Gateway space station, it's going to look a lot more like Skylab, certainly in the beginning. There are no tracking data relay satellites around the moon. There's discussion about putting relay satellites out there, but Gateway will serve as a communications hub, but of course it's only one piece headed around the moon. And so when we talk about mission control, we have the benefit of having flown the International Space Station for 20 plus years, and so that's a lot of practice. And things go wrong, but we have really learned what the crew needs on orbit in terms of communication with the ground and their families. And Mike can talk more about that. He's lived there. What they need in terms of exercise, what their days look like, how we can break the tasks into things that actually make some sense to them, and you know, they can do all of the science that we need and the maintenance that we need of that amazing platform. And so it's an interesting question, because it's almost like we have to go back to the future to learn about the development. So let me see if I get it right. You guys launched 10 days, right? So if you think about it, right, they put Skylab up on orbit, and 10 days later, the crew launched. And just the timing of that, to have the crew ready to go, to have the rocket not run into weather, to get them up on orbit, to get the spacewalk plan to effectively save the Skylab, right? This is the type of stuff that we're going to run into with all of our new vehicles we're building out in our HO for Gateway, and then down to the surface for Artemis. So we have learned a tremendous amount, back to the question, but I actually think we have to be in the mindset of space cowboys or space cowgirls a little bit more than what we see on orbit every day. So we got to take our ISS knowledge, and then we've got to kind of go back and grab all that Skylab knowledge and put them together, and I think that's where we really need to be. So, Mike, I'll let you add.
Yeah, and I agree with all of that. I was a science Capcom in the shuttle Mir days in the Russian Flight Control Center, the TSUP. It was a very interesting time to be there, and the comm more resembled Skylab than what we have today. There were ground stations. Every once in a while, one of the satellites would work, but a few minutes per orbit, we were able to talk to the crew, and we were trying to get a robust science package together, and I often heard, how do you expect us to get any work done if you keep calling us to comm? Well, the current paradigm is that there's always comm except for a couple of minutes break. And so the Flight Control Center has to adapt just like the crew does. And what these guys had was a tremendous amount of autonomy, because we didn't have that continuous comm. And so they also had to adapt around that and operate this, at the time, very complex laboratory. You can't operate the station that way, the ISS right now, because the throughput that's expected for science is huge, and it's really, really complex. But I agree, we'll be back to the future with Gateway, and both parties will have to adapt. The crew will have to become more autonomous, and that's both a good thing and an uncomfortable thing. And when sometimes you hear crew on board now saying, hey, when are you going to answer this question that I just asked you 20 seconds ago? You see how we adapt to a program. And so I think we'll start to resemble more Skylab with Gateway. And I'm actually looking forward to that.
Awesome. Okay, and I love how we have adapted our time, that we were on schedule, so we can actually open it up for questions from the audience.
I got a funny story.
Okay, you can tell a funny story while while the audience is thinking of their question.
When Alan and Bean and Owen, Gary, and I found out that we weren't going to be able to be extended for the 2 or 3 weeks we wanted to, the ground said, we are going to, however, leave you up there for 59 days instead of 56, so you're going to have 3 extra days. But there's a problem, because we had a change of skivvies every other day. And they said the problem is that on day 58, you're going to have no skivvies. And but we'll come up with a solution to that problem somehow. So they did. And so we have a solution to the skivvy problem. The solution is you're going to get to change your skivvies today. The problem is, however, Al, you changed with Jack. Jack, you changed with Ellen. So, you never lose your sense of humor. So when Al and I were up there, we knew that when we got back, we were going to be on the backup crew for the flight with the Russians, and had made that kind of evolution finally. But we were not allowed to take any pictures over China or over Russia. So we looked down there with our eyeballs, and we could see the Tam launch site and all those kind of things, but weren't able to photograph them. It was a little different, though, when I flew on the Space Shuttle Columbia. You could take pictures of China and Russia, and so we did. And one day we were flying over some place in southern Russia, and I looked out the window and I saw this beautiful blue, like a jewel blue lake, crystal clear. It wasn't big, it was just a nice round lake. And it was in the background of a nice sandy tan desert. And it's just a beautiful picture, so I took a shot of it. And then at the end of the mission, later on, Gordon Fullerton, my co-pilot, and I were invited to go to China for 3 weeks and meet with the people there and tell them about space flight and go talk to people in schools and in the press and whoever. And we were just cleared to say anything we wanted to. And we were showing some film. And we showed some slides. And we had a big audience, bigger than this, mostly of engineers out there. And we had an interpreter because my Russian wasn't good enough to tell them everything they needed to know. So we were going through this retinue of pictures, and that came up to the one with the blue jewel in the sandy desert. And there was a sound. I felt a rising, it's kind of a humorous rising out in the audience. And the interpreter said, "Next slide, please." And we went on. And I didn't know why we didn't spend more time looking at that beautiful picture. So in the evening, we had a kind of a social event, and I found him in a corner somewhere where he couldn't be observed being compromising his communist background and so forth with his Yankee. And I said, "Sir, could you tell me when we were just showing these pictures, and I showed this picture of the blue lake in the desert, very beautiful picture, and there's a little rise in the audience, and you said, 'Next slide, please.'" And he looked all around. He says, "Come over here where nobody could see him." I said, "Why was that?" He said, "I think that was a nuclear test site." A lot of good stories.
Okay, we got one question here.
Sure. How did your perspective on the planet change after each of your initial flights?
Could you repeat that, please?
How did your perspective of the planet change after your initial flight?
My own microphone. You know, at the end of that skywalk to pull up the solar panel, we had a few minutes left, and I went up the ladder at the Apollo telescope mount, which was the big mount for the solar telescopes, and put my feet in the foot restraints up there and stood up. And it was the middle of the day, and the Earth was directly below me, and the sun was directly above me, and I'm looking at the clouds and the water and saying, "Oh man, this is just king of the hill. I've never seen anything quite so magnificent." And I hope that some of the younger members of this audience, and thank you all for coming, it's so much fun to talk about yourself, will be able to see that site someday, either with NASA or just on a nice vacation. So that didn't directly answer your question, but it sort of said, you know, basically, I knew God created a beautiful planet, and my opinion did not get changed.
Is there another question? Okay.
What's the experience like of blasting off into space?
What's the experience like of blasting off into space? What is it like sitting on that rocket and it's taken off and you're going?
Well, I went on two of them. One was a space shuttle, and the other was the Saturn rocket. And they're remarkably different. Sitting on the Saturn rocket, you get out there about 3 hours before liftoff. The ground crew helps you get strapped in, and you get comfortable in there, and you respond to the call from the flight director there at the Kennedy Space Center. They have a lot of the checkouts they have to do, and you're part of some of them, and you tend to fall asleep. One time, in fact, I fell asleep there while I was out there, and my heart rate went way down, and they said, "Hey, his Lawson was still alive, so somebody hit me." Yeah, he's still alive. But when the rocket lights off, Saturn rocket, you get an ignition about 9 seconds before liftoff, and it counts on down. You can feel a little bit of something going on down there. And then right at the liftoff time, the main engines are ignited, and there's heavy vibration as you leave the launch pad, and you know you're going to go somewhere, and I hope it's straight up. And as you clear the launch tower, then you make a roll maneuver to put your head in the right your launch is upside down. And the first stage burned for about 2.5 minutes, as I recall, really laid you back in the seat. Then all of a sudden it shuts off, throws you forward in the straps, and the engine quit. And then you wait for the first stage to deploy. And the second stage, you say, gee, I hope that the second stage lights. And sure enough, it comes on, and you go another 6 minutes or so and gets you into orbit about 8.5 minutes. So quite a smooth ride, though. It doesn't shake and vibrate a whole lot. The shuttle's different. It lights off with a big bang, and when you go at solid rockets that light immediately and slap you in the back, and you're on your way, and you have this heavy vibration like this, like for about 2.5 minutes because of the solid rocket boosters. It's like running over railroad ties real fast with a rental car. And then when those engines quit, all of a sudden they're off, and it throws you forward in the straps. The engine quit. And then there's a big flash of fire and smoke around the cockpit as the jettison motors fire to take these solids away. And your main engines are continuing, of course, so they continue and take you up in orbit. And it's a much smoother ride after that. So those are some of the differences in the takeoff and the liftoff and the launch of those two kinds of rockets.
Let's see. Are there any more questions? Oh, okay. There's 2 hands. There's only one question. I'm going to go with her.
What was the most food that you missed the most when you were in space?
Okay. What was the food that you missed the most when you were in space?
I didn't miss anything. I ate it all.
Our food was really pretty good. We had very strict dietary requirements, just so many calories, so much protein all the way down. But they did a heck of a job. And I want to shout out another person. Her name was Rita Rapp, and she was our chief dietitian. And she worked with us to make that meal, those meals that were so constrained, to taste really delicious. And she did one other thing. On launch day, she slipped a pack of Wrigley's chewing gum in my spacesuit pocket because I smoked and I was about to quit.
One thing about the food system was part of a major experiment, medical experiment, and we had our menus were all decided several months before we lifted off, because all the food for 3 crews had to be lifted off. Every crewman had a different menu, and it was every week you had the same menu, but yours was different than the other guys. And this was a problem that we were trying to solve. How does the body metabolize food in space, and what happens to the body when you eat those certain kinds of food? So we had about 60 different kind of food items, as I recall, and some of them were dried juices that you can mix with water. Put 8 ounces of water in and drink it up. If you didn't drink it all, you had to report it because it had a certain number of minerals and calories and so forth. Each food item was very carefully known as what it had in terms of calories and minerals, and so the doctors wanted to know what you're eating. And we each had different menus, and they came in cans, and we don't have to go into all that, how it was done, but nevertheless, if you didn't eat something, you had to mass it. And that is, you couldn't weigh it. You had to tell them how much you didn't have. So we had something invented by Dr. Bill Thornton, this little slider thing. You put it on there and let it go, and it slide back and forth. And the frequency with which it moved was proportional to the weight of food you didn't eat. Same with your body. It had a bigger one, but nevertheless, so it had maybe very, very calibrated amount of food that went in. Well, if you want to know what happened to the food and how it affected your body, you got to know what comes out. Now, that's another colorful story. And so there was a way that we had that each bowel movement was put in a bag, and it was dried and brought back, and it could be analyzed. Urine the same way. We each had a separate urine drawer, and a amount could be measured every day. And you could bring a little bit of it back, about the size of 2 ice cubes, frozen, so that could be analyzed, so they could figure out what was going in and what was coming out, and thereby understand how the body was metabolizing food. But the food system was not a simple thing. It was very, very well calibrated, very well thought out, and very well followed, and the results, I think, were quite accurate.
So, I mean, we've had lots of great discussion. We're going to have to cut off our panel for the evening. And I know that, you guys can please hang around and maybe ask some questions when we get done. Want to just thank the panelists. What a wonderful opportunity for us to celebrate the 50th anniversary of Skylab, but also to celebrate the achievements that we've made thus far, and as Holly said, that we'll be making going forward into the future. And 50 years from now, there's going to be a panel up here talking about what they've been doing at Mars. So, with that, we're going to say good night, and thank you all.